Hello everyone, welcome to the world of Lean Six Sigma. I am your mentor and coach Mohit Sharma. I have been receiving this request to make a video on Green Belt Training. Today in this video, I am going to help you understand some of the concepts of Green Belt Training. So let's begin. So before we understand anything, let us understand what is Six Sigma. So Six Sigma means it is 3.4 defects per million opportunities. Means in 1 million opportunities, you can only create 3.4 defects, and that is when it is known as Six Sigma process. So if you go by the definition of it, it talks about that the term sigma is used to designate the distribution or spread about the mean, or mean is also known as average. Whenever there is a distribution around the mean or spread around the mean, that term sigma is used to represent that. For a process, the sigma capability, which is also known as Z value, it is a metric that indicates how well the process is performing. So higher the sigma capability, the better the process is. Sigma capability measures the capability of the process to produce defect-free output. As I previously said, it is only 3.4 defects which are allowed in a Six Sigma process. So just take a pause and understand this. Do every process need to work at Six Sigma? There are processes where customers are happy at 95% accuracy as well. There are processes at which 3.4 defects in 1 million opportunity is too high, like in aviation industry. Wherever there is a life and death situation, Six Sigma looks very small. They need to work on 12 Sigma, 15 Sigma, because it is the life of the person which is involved. I gave you the example of aviation industry. It could be your medical industry, medicines. When you are producing medicines, you don't want to produce 3.4 defects in 1 million opportunity. Likewise, the other example in a services industry, wherever we are working in a BPO IT kind of an industry, their customers' expectation is, for example, is 95% accuracy in the type of work that you do. So you do not strive hard to achieve 99.9998%. The point which I am making is these are the numbers which are defined here. So we need to decide what is best for our process as a sigma goal. Some processes may be at 2 sigma. Their current goal could be to reach 3.5 sigma in the coming time. Let us understand before we go ahead what is data. Data is the set of records which provides us meaningful information. The set of records which cannot provide you meaningful information is no data. So data can be divided into two parts. One is discrete and one is continuous. So continuous data which can be measured on a continuum or a scale, or the data which you can break further in terms of you can put a dot and write further, like 11 meters and 15 centimeters. So you can write it as 11.15 meters. Discrete data, on the other hand, is further divided into three types. One is called binary, ordinal, and count. Binary data has two outputs, yes or no, pass or fail. Ordinal data is in the order. For example, ranking in the class, first, second, third, fourth, fifth. You may not have seen 1.1 rank in the class. Somebody is ranked 1.1 in the class. Two people can come first or two people can come second, but you will not find that there is somebody who is ranked 1.1 in the class. So this data you can't break it further. That is why it is discrete. And the last one is the count data. Count is again a discrete data type in which you are counting the number of people in the room, number of chairs in the room, number of calls that you have taken today. You can't take 4.5 calls, right? You would have taken 5 calls, but on fifth call you were not able to maybe solve the query. So you will not say that I have taken 4.5 calls. You have taken 5 calls, but the resolution could have been provided on 4 calls only. Moving on, types of distribution. So we have normal distribution data and skewed distribution and uniform distribution. And you do not bias that data pattern, it will follow normal distribution. Like people joining a call. If a call time is at 8 o'clock, some people will join at 7:55. Some more people will join at 7:56, 7:57, 7:58, and majority of the people will join between 7:59 and 8:01. And then this dip will come. Some people will join late also, right? That is why this dip will come. If you do not put a bias in it, the distribution that the data will follow is normal distribution. The next is the skewed distribution or non-normal distribution. If you start putting a bias in this distribution, for example, you say time of call is 8 o'clock, the bridge will open at 8 o'clock only, call bridge. So nobody will be able to join before that. So everybody is waiting for 8 o'clock, and as soon as 8 o'clock happens, all of you join suddenly. So this peak will come, and then the tail will follow. People who will join late will join late. So this tail will follow later. The third distribution is uniform distribution, in which there is a call and everybody joins at 8 o'clock, approximately at the same time. The next thing that we need to measure in data is the central tendency of the data. You always report data's central tendency with the help of mean or median. And the last thing that we have to study about data is called variation. So variation is indicated by standard deviation or interquartile range. So why we have to study all of these is because whenever we work on data in our project, we need to know what is the data type, what is the data distribution, how we are going to measure the central tendency, whether it is mean or median, and how we are going to study the variation, whether we will study standard deviation or range or interquartile range from the data. So just last thing that we want to know about data is when the distribution is normal, we use mean and standard deviation to represent the data. When the data distribution is non-normal, we use median and interquartile range to represent the non-normal data. With this, we will move ahead and start the first phase of DMAIC, which is defying phase. It is very important to define what is the voice of the customer and what is the voice of the business. So you have to define both the things together so that you know on a single slide what is the voice of customer and what is the voice of business. If both the voices are the same, then only you take that as a project. Let us take this example to understand it a little better. The example here is there is a company which manufactures jam and they have outsourced the printing of the labels on the jam bottle that they used to put to some other company called ABC Printing Company. ABC Printing Company is receiving some complaints from XYZ Jam Manufacturing Company. Customer is saying that product wrappers they do not reach on time. Then the issue is that overall product supply is delayed. So XYZ manufacturing company has prepared the jam, filled them in the bottle, but they are waiting for the product wrappers to reach. So once the product wrapper reaches them, then only they can ship the product. Because of wrapper delay, the overall production is delayed. Overall product supply is delayed. So wrapper should reach the customer within 1 day of placing the order. This is the critical customer requirement that they have. And this leads to CTQ. So ABC Printing Company did some research. They calculated some data for last 6 months, and then they saw that the turnaround time of printing the wrapper is 4 days, and they want to reduce it to 1 day. Same way, voice of the business says that the customers are raising concerns and they are losing confidence on our organization. Why? Because we are delaying their product, which is the printed wrappers. What is the issue? It is impacting the customer satisfaction, and the other issue could be that they could lose the business to competition. And what is critical business requirement? The wrappers should be delivered to the end customer within a day of placing the order. And they also reach to a point where they say critical to process is reducing the turnaround time for printing the wrappers from 4 days to 1 day. So when both these CTQ and CTP are same, that is when you can pick this as a project. So project charter is the most important element of a DMAIC project or any other Six Sigma project. So why it is important to create a project charter? Because project charter is a snapshot of the project. It is an arrangement between the management and the project team about what is that they are going to deliver through this project. They have defined the scope, the time, and everything in this particular project charter. But there are some common mistakes that people make. They misunderstood the problem, and that is when they create a wrong project charter. While selecting the project metric, they make a mistake. They're working with the data with a special cause in it. I'll explain that when we reach to the analyze phase. They are working on the process metric, not on the output metric. So process metric is the productivity versus the output metric, which customer is really worried about is the cycle time reduction. Which ultimately, if you reduce the cycle time of a transaction, you will ultimately increase the productivity. But people are more worried about the process metrics. They are not worried about the output metric. So that is the mistake that they make when they are picking up the problem statements. So this is the project charter, business case, problem statement, goal statement, scope of the project, milestone and team charter. I have explained this beautifully in my videos, so I'll attach the link in the description box so that you understand how to create an effective project charter. The next thing that the team has to do is to identify what are the potential root causes to this particular problem. And to do that, the effective tool that is used is fishbone diagram. So we are saying identifying potential axis with the help of fishbone diagram. It is also known as Ishikawa diagram or cause and effect diagram. So I will not get into the details of how a fishbone diagram is created. I have elaborated that so many times in my other videos. I will attach some of the links here so that if you want to know how a fishbone is to be created, so you can do that. But the important point that you have to learn here is that whenever there is a problem, which is the effect, which is the head of the fish, it is the effect of the or the problem, which is the head of the fish, it has to be supported by these certain causes. So they are broadly divided to 6 categories. One is called man, machine, material, mother nature, measurement, and method. So this broad categorization of the causes can be done, and whenever you are in a brainstorming session, identify the maximum root causes or causes to this particular problem. Then the next step, when we move ahead in a DMAIC kind of a project, is to identify these causes and find out on some of the causes you can collect data or not. So you need to create a data collection plan next. So once you create a data collection plan and you want to collect data, so before you go ahead and collect data, you need to know one thing which is called measurement system analysis. What is measurement system analysis? So you cannot do a project until unless your measurement system is correct. You cannot improve somebody's performance if the person with which the person is measuring is the equipment is not correct, right? If you are using a weighing scale and there's a bias in the weighing scale, you can't teach somebody how to weigh a product until unless you fix that bias. So in our kind of industry, where in mostly services industry, where people are the measurement system, you always see that there is a core team which is working on transactions. There is a team sitting behind them with more experience, but they are less in number to check whatever these 20, 30 guys are doing is accurate or not accurate. So they are called quality resources. So our measurement system is those quality resources. How are we going to identify whether these quality resources are doing their job correctly or not? So this aspect is measured by gauge RNR, gauge repeatability and reproducibility. And this is part of understanding the measurement system or identifying whether the measurement system is correct or not correct. There are 3 things that we need to see here. One is called repeatability. Repeatability is within the individual. The individual has to say that it is a correct transaction today, and after 20 days also, that person has to state that it is a correct transaction. Reproducibility is between the individual. Two quality resources are checking same type of transactions. They should be able to reproduce their thoughts. They should be able to say, both of them should be able to say that this is a correct transaction or an incorrect transaction. Both of them should say, by looking at that similar transaction, that this is correct or incorrect. And then comes the third thing, which is called the accuracy of this overall judgment. Say I'm saying this is a correct transaction. My partner is also saying it is a correct transaction, but actually it is an incorrect transaction. So we are repeatable, we may be reproducible, but if we are not accurate, it means there is overall we have an issue. So we need to meet with the standard. So accuracy comes from a standard source. So this standard source could be your customer. This standard source could be your an overall 25 years experience guy in the process. Anybody who has an authority to say, okay, this is something which everyone should compare yourself with, right? So that becomes your standard, and it tells you about the accuracy of this measurement system. Suppose we have this data in Minitab. So we have given 16 transactions to 3 operators. So they have given their judgment on these transactions, whether they are true transactions or false transactions. And then we have in the last column, we have standard. Standard means somebody from the customer end has validated these 16 transactions, whether they are true or false. After 15-20 days, we have also given them the same transactions to check. So you can see in column C40, operator 1 second trial is there. This is to check whether operator 1 to 3 are repeatable or not. They can repeat their earlier judgment in the same way or not. And the last one, which is standard, which I have already spoken about, is to check whether they are accurate as well or not. This is attribute data. So what we are going to do in this part of the training is we will only cover attribute gauge RNR. If you want to learn what is continuous gauge RNR, where it is used, so I have video on my channel and I'll put the link in the description box below. We will go to stat, quality tools and attribute agreement analysis. We will go to multiple columns and we will select operator 1's first trial and operator 1's second trial together. Now we will select operator 2 first trial and operator 2 second trial together. Now for operator 3. Number of appraisers we have is 3. Number of trials we have is 2. So 2 trials per appraiser. That is what we have. Name of the appraiser you want to write down. Maybe A, B. It could be A, B, C or Abhishek, Bachchan and company. And the last one is known standard. Here we enter column C7. And we click OK. So if we look at this particular box in which it says all appraiser versus standard, this value is 87.5%. This value should be greater than or equal to 90% to say that gauge has passed. But this time the gauge has failed. It could have a repeatability, reproducibility or accuracy issue. So that can be seen in the data above this. Between appraisers means reproducibility. So 93.75, it means there is one instance in which all 3 of them do not agree. Each appraiser versus standard. Each appraiser versus standard means accuracy. So appraiser A and B has accuracy issues in 2 cases and appraiser C has an accuracy issue in 1 case only. And if we talk about the repeatability, they both repeat the same in all the 16 transactions. So 100% repeatability, but accuracy is the problem and reproducibility is the problem. Now what the team has to do is they have to train these folks on the areas in which they lag. And once they are trained, then again the gauge should be done before we collect data on it. Because if the team is measuring us incorrectly, then there is no point collecting incorrect data. So after that, the next thing that we do is to move into the analyze phase. In the analyze phase, because it is a Six Sigma project, we should also know what is the sigma value of the process. If my project Y is discrete, I will have to calculate sigma value with the help of this formula, which is written here. Norm sin V 1 minus defects upon opportunities plus 1.5. Suppose the number of defects are 50. Opportunity per unit is 5. It means one unit can fail in 5 different ways. And total units are 500. So the sigma value is 3.553. So total number of defects are 50 and total opportunities are 2500, which is total units into opportunity per unit, which is 500 into 5, which is 2500. So this sigma value is 3.553. So this is how you calculate process sigma value for discrete data. For continuous data, I will attach the link of the video which will help you understand that, because it is a very lengthy or very time consuming process that you need to understand it in detail. So I'll attach the link in the description box below. The next 2 things that we should do is to identify whether the data is stable, which is done with the help of a run chart, and whether the data which we are going to use in the process is normally distributed or non-normally distributed. Once the data is stable, which is with the help of run chart you can find it out, and the data is normal or non-normal, with the help of the p-value of the graphical summary you can highlight that. With this, you will be able to understand which kind of hypothesis test, which kind of tool that you are going to use in the next upcoming slides. So in Minitab, in sheet number 1, in worksheet 1, I have some data on cycle time of the process. Cycle time is continuous data, which is my project Y. I want to check whether it is stable with the help of a run chart and whether it is normal or non-normal. So the first thing that I'm going to do is stat quality tools run chart. Single column, I will enter cycle time. In subgroup size, I will enter 1. I will click OK. So you have to look at these p-values, which is clusters, mixtures, trends, and oscillation. All these p-values, if they are greater than 0.05, it states that data is stable. There are no special causes in the data, and you can work on this data and do a deep dive in terms of analysis of the data. And to check the normality of the data, you will go to Stat, Basic Statistics, Graphical Summary. Under Variables, you will enter Cycle Time and you will click OK. P-value here indicates the normality of the data. If it is greater than 0.05, it it means that data is normally distributed. So in our case, data is normally distributed. Next, you have to identify which of the x's are significantly impacting the project y. This can be done with the help of hypothesis testing. So why hypothesis testing? What is why hypothesis testing? We have detailed videos on all of this on my channel. I will attach the link in the description box below. But what I want you to understand here is that if your y is continuous and your x is continuous, what type of hypothesis test you should do? So hypothesis test that you should do when your y is continuous and x is continuous, the test is simple linear regression. When your y is continuous and your x is discrete, and your y is normally distributed, you will have to use ANOVA test. And when your y is continuous and x is discrete and y is non-normal, you will use Moore's median test. When your y is discrete and your x is discrete, you will use chi-square test. So what we are going to learn in this training is how to perform simple linear regression, one-way ANOVA, Moore's median test, and chi-square test. So for that, for example, we have cycle time data here, and our y is normally distributed, and associate is the discrete x. So the test that we are going to perform is known as one-way ANOVA test. So to perform the test, we will go to stat ANOVA one way. In the response, we will enter cycle time, and in factor, we will enter associate, and we will click OK. P-value which is less than 0.05 indicate that this x is a contributing x. This is a significant x. So we have to work on associate. So there could be some associates which are taking more time. There could be some associates which are taking lesser time. What is that the associates are doing which are taking lesser time to process a transaction? And that can be replicated across to the other associates. So there are three associates here. Associate AS is taking 4.6 minutes only, and associate CD is taking 9 minutes. So there is a huge difference between the mean cycle time that they are taking to process a transaction. It means it is a contributing factor, and we have to take care of this contributing factor. The next hypothesis test that we are going to perform is called regression, simple linear regression. When your y is continuous and your x is continuous, cycle time, this is a call cycle time, for example, and C4 column indicates hold time in this case. Hold time is continuous, call cycle time is also continuous. So both of them can be tested with the help of simple linear regression. So for that, we will use fitted line plot, and the path to go to fitted line plot is stat, regression, and fitted line plot. In response y, we will enter cycle time, and in the predictor x, we will enter hold time, and we will click OK. If you look at this graph, it indicates that R square adjusted value here is 91.6%, which indicates there is a strong correlation between this x and y, which is cycle time and hold time. Whenever my hold time is increasing, my cycle time is also increasing. You can see the slope of this line. It means I have to reduce my hold time to reduce the cycle time of the call. Next hypothesis test is Moore's median test. For that, we are going to use the data in worksheet 3. So for that, we need to check whether project Y is non-normal or not. So I have some data in column C1. P-value of less than 0.05 indicates that it is a non-normal data. So now the X, which is branch in this case, is discrete X. So when your Y is non-normal and your X is discrete, we will use Moore's median test. And the path to reach there is stat, non-parametric test, Moore's median test. In response, we will enter cycle time, and in factor, we will enter branch, and we will click OK. P-value of less than 0.05 indicates that it is a contributing X. It means branch is a contributing X to the cycle time. Let us learn another tool or concept which is for discrete data. So now my project Y is also discrete. It is defect or not a defect transaction. Count of defects is a discrete data. So my Y is discrete in this case, and my X is associate. Associate is also discrete. I have to now perform chi-square test. Stat table and chi-square test for association. In rows, we will enter column C1, and in columns, we will enter column associate, and we will click OK. P-value of less than 0.05 here again indicates that it is a contributing X. Suppose we look at Mohan. Mohan is expected 5.9 errors from this data, and he is creating 10 errors. It means Mohan is the person who is creating more than expected errors. So guys, what I have tried here is I've tried to give you some idea or concept which hypothesis test is to be performed when your Y is continuous and X is continuous or discrete. If you want to know the detail of all of these, I have separate videos. It is not possible to cover everything in one video, and hence I have separate videos for all of them. I will attach their link in the description box. For all these hypothesis tests, I have separate videos for Way Anova, for Moore's median, for homogeneity of variance, for simple linear regression, logistic regression, chi-square test. All of them have separate videos on my channel, and they are explained in detail in those videos. So if you want to learn more, you need to watch those videos. Moving ahead, the next thing to do is to identify which of these x's which we have identified are significant, and now what is the solution to this problem. We use YY analysis. This is the improved phase of the project, by the way. So here, say for example, the root cause was less trained staff. So why the staff is not trained properly? Because there is no proper training plan. And why there is no proper training plan? The training plan is not created at all. So the solution to this problem is that we need to create a robust training plan. So this is how solutions are identified. The next in improve phase is implementation plan, which is 4W1H. What is to be done, when it is to be done, where, who, and how it is to be done. Training is to be given. By when it is to be given? 22nd of April it is to be given. Where it is to be given? In the boardroom. Who will give the training? The trainer one. And how the training is to be given? The module of the training. On day 1 this is to be taught, day 2 this is to be taught. Like this, a detailed training module has to be created, and that is how this implementation plan is created. After you implement all these solutions, you move into the control phase. The first thing that you need to do is control the improved state that you have already got. So for example, you have said that we will check 5 cases per person per week so that the accuracy doesn't go bad again, right? The feedback goes back to the agents after checking these 5 cases per day. When we have to start, there is a date which is given. Where on the floor, who will do that? Quality resource will do that. And how? He has to pick up 5 random samples from each of the associates every day. And what is the frequency of check? This is important. This is how this entire thing will be under control. See, if the QC resource stops checking the cases after 1 month, what will happen? The accuracy errors will again go unnoticed, and people will not know what are their mistakes, how they should improve. Feedback will not go back to them. So it is important to check the frequency at which these. So to check it frequently, the quality manager has to set up a control plan. The control here is that quality manager has to check every week whether this person who is the quality resource, is he checking the 5 cases per person per week or not. That is how the improved state will be under control. The next thing the team should do is to create a control chart and see whether the data which they have got after the improvements, that should be under statistical control. So there are different types of control charts, continuous control data control charts and discrete data control charts. Detailed videos are available on my channel. But what I'm going to do here is to create one control chart on this data, which is in column C2, which is cycle time after the improvement. So this control chart, the data is continuous in nature, and I'm going to use IMR control chart here. So to create IMR control chart, we go to Stat, Control Charts, Variable Charts for individuals, and IMR chart. Under Variable, I will enter cycle time after improvement and click OK. So if you look at this control chart, all these blue dots, they should be under these red lines, which is called upper control limit and lower control limit. So my upper control limit is 1.8 and my lower control limit is 0.207. So all these data points should lie within these two control limits. That is when it is indicated that the process is in statistical control. So friends, I have tried to touch every concept in this small video because green belt training is huge. So you cannot cover everything together in this 35 to 40-minute session. So what I did is I have given you a glimpse of what it will look like. So if you want to learn more about green belt training, you can watch these specific videos on my channel in the same sequence as I have explained in this training. So I hope you like this particular video, training video. And if you really like this video, please give it a thumbs up and share this with your friends. So if you guys think that somebody can use this knowledge and get benefited, so please share this video as much as you can. Thank you so much for watching. I will see you in my next upcoming video. Till then, take care. Bye bye.